right, today we're going to talk about solving systems of equations, but some of these equations might be nonlinear. So we've done linear equations, systems of 2 and 3 equations, and we're going to use the same general tools to solve nonlinear equations. So pause the video for a moment and see if you can come up with as many ways as possible to solve these two equations. All right, so here we have one quadratic and one linear equation. One way you could solve these two equations would simply be by graphing them. You put one in y1 and put the other one in y2 and graph it and see where they intersect. You would use your second calc and then that number 5 intersection to find the intersection points. One intersection point here would be 2, 4, and the other one would be negative 1, 1. So that's the solution to these equations. How else could I solve this? Well, another method would be substitution. When you choose substitution, you look at your equations and you look for a variable that has a coefficient of 1 or negative 1. So in this case, I chose the first equation and I just substituted it into the second equation. So y equals x squared, I just substituted that y into the y here for the x plus 2, and I got x squared equals x plus 2. Well, now I can subtract the x and the 2 over, and now I have a quadratic equation that I can solve. So now I know that x equals negative 1 or x equals 2. But don't forget to plug these values in and solve for your y values. So many times students forget to do that extra step. Remember, your solution is an xy. It's an ordered pair. So if I plug x equals negative 1 into the first equation, I will get y is 1. And if I plug 2 in, I get y is 4. So my solution to this system of equations is negative 1, 1 or 2, 4, just like we saw when we graphed it. So how else could you solve this system of equations? Well, you could solve it by elimination. So by elimination, you're going to add the two equations. You could put them in standard form if you want, but in this case, it really isn't going to matter. I'm going to multiply the second equation by negative 1 so that my y's will end up adding to 0. And I'll have x squared minus x minus 2. So now I have a quadratic equation. It's factorable. So I know that x is negative 1 and x is 2. Again, I'm going to substitute that back in to get my y values. And once again, I get negative 1, 1 or 2, 4. All right, let's talk about solving nonlinear systems. So how many solutions would there be for a system of equations that has a quadratic equation and a linear equation? Well, I could have no solutions where they don't cross at all. I could have one solution where this line would be tangent to the parabola, tangent meaning that it only crosses at one point. Or I could have a line that cuts through the parabola at two places and I would have two solutions. How many solutions would there be for a system of equations when I have two quadratic functions? Well, once again, they could not cross at all, and I would have no solution. The two parabolas could be tangent to each other, which means I would only have one solution. Or they could cross like this one here, and I would have two solutions. Here's an example of two quadratic equations. The simplest way to do this would be to simply add the two equations together. I would get 3x squared, minus 3x equals 2. Now I simply have one quadratic equation. I can just subtract the 2, and I would solve this using the quadratic formula. And you can see here that I have an imaginary solution, so that means I have no real solution. So what would these graphs look like? Right? They would look like this. They wouldn't cross at all. How many solutions are there for a system of equations with a circle and a linear function? All right, well, here I have a circle and a line. They never cross, so this would be no solution. Once again, here I have a circle and a line that is tangent to the circle, so I'd have one solution. And here I have a line and a circle, and it goes through the circle, so I would have two solutions. Now, some of you might not be familiar with the equation of a circle, but the equation of a circle is x squared plus y squared equals the radius squared. So x and y would be any point on the circle, and then r would be your radius. So the general format of the equation of a circle is x squared plus y squared equals r squared. So if we have these two equations, this one here is already solved for y, so I can just substitute this one into the first equation. Remember, when you expand this binomial, you're going to get a trinomial. Combine all my like terms, set it equal to 0. Simplify the equation by divide everything through by 10. And now factoring. So now I have x equals 3. Once again, I'm going to plug that in to solve for y. I could plug it into either equation. I'm going to plug it into the linear equation because it's a little simpler. And so I get y is 1. So my answer is 3, 1. So which one of the graphs would this look like? Right? It would look like the one that's tangent because it only has one solution. All right, go ahead and finish solve quad 15. And if you have questions, let me know.